In another video, I shared with you that organic chemists are generally a lazy lot when it comes to drawing organic molecules. And that had to do with the condensed structural formulas. Now I'm going to show you an even lazier way of drawing organic molecules. So for example, if I were to draw a molecule of propane, propane might look like this. CH3, CH2, CH3. And if we were to do that like a skeletal structure, we might put some single lines in here. So we might go like this and go CH3 dash CH2 dash CH3. Okay, and this would be propane. Three carbon atoms. Now, a line angle drawing of this would be a shorthand simplification, lazy way of drawing this molecule. And it would look like this. And you might be going, what? Well, here's what's happening. At each one of these points would be a carbon atom. Now, they're not drawn, but there would be a carbon atom here, here, and here. And it's assumed that we recognize that carbon atoms like to form 4 bonds, and so there would be hydrogen atoms in here to fill those 4 bonds. So for here, this carbon atom already has 2 bonds, one here, so there would be a hydrogen and a hydrogen, like this. And these carbon atoms on the ends, each of these would have 3 hydrogens, like this. And so we can see that this would be CH3 dash CH2 and CH3. Okay, and all this would be is just that zigzaggy line. Would just look like this. That is our line angle drawing. All right, making things as simple as possible. Now, if I were to draw something a little more complex, let's try something like 2-methylpentane. So, methylpentane. Now, if I were to write out the formula for this, or the skeletal structure for this, pentane has got 5 carbon atoms. So I would go 1, 2, 3, 4, 5 carbon atoms, like this, 5 carbon atoms. And then off of the second carbon atom, there would be a methyl group. So 1, 2 would be a methyl group, like this, CH3. And then I could put my other hydrogens in here. This would be CH3, and then CH, and then CH2, CH2, and then CH3, like this. There's my 2-methylpentane. And if I wanted to then draw the line angle drawing for this, I've got 1, 2, 3, 4, 5 carbons, and I'm going to make a zigzaggy line here. So I'll go 1, 2, 3, 1, 2, 3, 4, 5 carbon atoms. And then I have a methyl group coming off of the second carbon. And I'm just going to number these just to kind of help me figure this out here. I'm going to go 1, 2, 3, 4, 5 carbon atoms. And coming off of the second carbon atom is going to be a methyl group, and that would look like this. So at each one of these points, here, 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 these are all carbon atoms. So this would be our line angle drawing for 2-methylpropane. And if I were to draw something else, let's try another one here. Let's try 2,3-dimethylbutane. So I'm going to go 2, 3 dimethyl butane. 2,3-dimethylbutane. So butane is going to be 4 carbon atoms. So let's do 1, 2, 3, 4. And I'm going to number these here. I'm going to go 1, 2, 3, 4. And it is 2, 3. So I will go like this. I'm going to put a methyl group here. And 3 is going to put another one here. And then I can fill in the rest of those carbon atoms. So this would be CH3, CH, CH, and then CH3. Because remember, each carbon atom wants to have 4 things attached to it there, all right, or have 4 bonds. And now to then do my line angle drawing, I'm going to have 1, 2, 3, 4 carbon atoms. So 1, 2, 3, 4 carbon atoms. I'll go ahead and number these. 1, 2, 3, 4 carbon atoms. And then I'm going to put on my 2 methyl groups here. We'll go 1 and 2. So here we have 2, 3. So 2, 3, 2, 3 dimethyl butane. Now, I don't know if you can get any lazier than that, but this is how organic chemists do the shorthand, and they just assume that you can look at this and see where the carbon atoms are and fill in the hydrogen atoms. It's kind of like a neat little secret code that organic chemists have, and now you have the key. You can decode this, and you can take this and turn it into something like this. We might take a look at our cheat sheet for naming organic compounds. We recognize that pentene Hello? Yes, this is.